for coming. It's great to be here. I missed last year in this venue, so this is a huge upgrade from 2 years ago, which was the last time I was here. So another big thanks to Silex Labs and Alex and everyone else putting this event together. This is pretty nice. So anyways, the second thing I'm super excited about is I get to introduce Haxe and Lua together and talk a little bit about the new target. And so the premise of this talk is this image, which was true as of a couple days ago. Everyone's familiar with this phrase and this image. And my contribution was this. So we have a new member of the family. Haxe can now target Lua, and I want to talk a little bit about Lua and why I think it's a compelling target, and why I think you guys should get interested in it, and talk a little bit about what you can do with it. So there's various programming language popularity contests out there. So take these with a grain of salt. But this is basically a chart of a huge portion of the most popular ones. Measured on two axes. One is the number of GitHub projects, and one is the number of Stack Overflow tags. And the text is a little bit small, so I'm just going to go ahead and highlight this. There's Lua, which is surprising, because that means the farther you are in the upper right, that means, by both those metrics, you're doing very well. So it's in the 75th percentile or so. Of all languages, which was surprising to me earlier on when I looked at this. And so you can get the full spread of like what Haxe, where Haxe falls, which is more or less in the middle of the pack, versus everything else that it targets. And it's clear that we've kind of got the high end of that covered. A lot of the first class targets, such as that are used, almost everywhere, such as C and Java, JavaScript, you name it. They're all clustered in the upper right. But then Lua is actually moving that direction. So I think it's definitely a target to watch. And so why is that? Why are people getting interested in Lua? And one is it's actually very fast as an interpreted script language. And then on top of that, there is an environment called, a platform called Lua JIT, which is a very fast JITting compiler. So once again, these is going to be a little bit small. But Lua shows up in here, and these sort of canned benchmarks. This one is looking at solving a Sudoku puzzle. This other one is looking at matrix multiplication, pattern matching, counting unique strings in a dictionary. Lua basically will hold its own against virtually anything, any language, static, compiled or not. And Lua JIT will, it's now showing up, like if you want to say that your target's fast, you have to compare it to Lua JIT and say how that stacks up against that. The other really compelling thing about Lua is that it's the base quote unquote vanilla install for Lua is tiny. It's about 100K. So it's used a lot in certain cases where you want to put an embedded scripting environment on an embedded device. Where the memory constraints might be severe. So it's very popular for that. So this is, once again, you can strip down PHP and JavaScript and Python. People do that all the time. But you're also, you're breaking with sort of the default path of those targets. And if you just sort of keep to the normal install for all those targets, they're many orders of magnitude bigger than what you get with Lua. So Lua's designed to stay small. And because of that, like I said, it's typically bolted on for a lot of different applications, and in particular, game scripting is very popular with Lua. So World of Warcraft has a really nice script interface to a good chunk of its API, and people have gone completely nuts with that. This is a Lua editor written in Lua as a plugin for World of Warcraft. There's books on this. In addition to World of Warcraft, it's the first class scripting engine for CryEngine, which is a high-end 3D gaming platform. And then one of my personal favorites, Baldur's Gate, uses that as well for all the NPC dialogue and branching interactions there. On top of that, it's also becoming very popular for web development. So if anyone uses Nginx as a framework, it has a Lua interface now. It's one of the fastest things you can use to serve web pages. It also, Redis has a Lua in its API. There's various web frameworks that wrap Lua, OpenResty and Sailor. And then it's also big time in the game community. So there's various frameworks that are available. I'm actually not personally familiar with some of these, but maybe some of you guys are in the gaming community. But yeah, it pops up in a lot of different places, including scientific computing. There's an editor that I'm interested in called NeoVim that uses it. It's used as a scripting layer for a lot of Adobe products, and it's used for protein folding in other scientific domains. And on top of that, I'm not the first person to come along and say, hey, Lua is interesting, we should, I want to figure this out. From the point of view of the Haxe community, other people have dabbled with Lua and tried to integrate Lua. So there was first and foremost, I was excited, there was an unfinished Lua target around 2008 that was geared towards Haxe 2 that never quite reached the finish line. Then there's various wrappers. There was a special JavaScript compiler that could output Lua. And then there is different types of native bindings that people have put together that interface with primarily CPP code. And then there was an interesting article where Nicholas was comparing Lua to Nico and kind of investigating some of the design trade-offs involved there. So Lua kind of shows up a lot in the way that in the Haxe community, just in trying to integrate it somehow. It seems like it was close. Lua is very similar to JavaScript, and that's something that we have a very strong target for. It does a lot of nice things. And when you look, you kind of squint your eyes at the code. There's some parts of it that look kind of JavaScripty, and you're like, oh, this, Lua has meta tables, JavaScript has prototypes. Those kind of seem the same. There's obviously, the first-class functions as closures. There's this sort of catch-all hash that can function as an array or an object. And it seems like that's a strong lead that maybe this isn't so hard. The problem is that Lua is, as I said before, is extremely simple. So they've stripped out a lot of things that most people would take for granted. And this was kind of my impression of my first week there. I was like, where are the integers? Where's binary operations? Like, where is all this stuff that I can't imagine, coding without? So there's an immediate challenge where you almost have to bootstrap basic functionality with Lua in order to sort of reach what I would consider sort of a standard coding experience where you can expect to use regular expressions, you can expect system libraries, networking, etc. Lua is very minimalistic, and it's not going to offer that out of the box. At least in this case, there's an asterisk there. They are starting to add integers finally in 5.3. So I'll talk a little bit more about the version differences. So I just wanted to give a really simple snippet and just show how a standard hello world main would translate into Lua. And you can see like functionally the layout is very similar. Obviously we kind of need to build up objects and then attach functions to them and then call those functions. And for the most part, this is for very basic hello world applications, this is pretty straightforward. And then just to give you more example of like what you're likely to see in the output and how that translates to what you actually entered in with Haxe code, any kind of bit operations get converted into special method calls that Lua can provide. So if you're doing any kind of bitwise calculations, you'll start to see those pop up in your output. And standard things like x++, Lua doesn't have that, so those have to get mapped into expressions and generated as part of the output. And this is just showing how kind of complicated it can get, where we've, since everything in Haxe is an expression, and in Lua expressions are much more constrained. You have to, in some cases, expand out the x++ and ++x into a series of temporary variable allocations, and then save those, and then apply them all in one expression at the end. The other challenge was for anonymous objects. Lua has a single type of table variable that basically covers covers use cases from arrays to hashes. But one of the big tricks there is that if you try to assign a null valued field, it'll just forget about it. So anything that comes across as null, you can't detect that it was ever there. So what I'm showing here is just there's a special wrapper function that I have to include that basically lets you save those references and detect that, oh, I did have a reference to this field of this name. So in the generated output, you will see a bunch of these helper methods that sort of that are sort of a preamble to make sure that Lua objects work the way that you'd expect them to in the other targets that Haxe does. And moving on, and then whenever you create an anonymous object, it will save the values. So here we've got X, Y, and Z. And it will save also the presence of X, Y, and Z in a separate table. So that just sort of makes those two things explicit. You've got the presence of that field, and then you've got the value of that field, because Lua sometimes will get forgetful, and you want to make sure that it always keeps that reference. This I'm going to gloss over very quickly. We need that strong anonymous class to do things like reflection. Like if we want to say, give me all the fields, we need to know if they're null or not. And then in object-oriented programming, we need to know which fields are part of which class. So with this new and improved anonymous object type that we bootstrap in Haxe, we can basically build the prototype or the class for all of the instance methods that we want. And as a quick overview, just with metatables, I mentioned that they're very similar to prototypes. This is sort of the magic that lets this happen. Metatables are basically, you can attach a metatable to a table, and then in certain cases, like if you say, give me this field, give me the field foo on this table, if it's missing, and it has a metatable, then it will invoke one of these special methods attached that's a part of this metatable. So in this case, this is how I handle everything from inheritance to missing fields to all of the different reflection checks I need. It's all metatable magic. So once again, when you see these in the output, that's what's going on. This is basically to make the tables behave like proper anonymous objects or proper OOP constructs. And to give one more example, so that with object-oriented programming, we're building on the anonymous table behaviors, and in this case, we're declaring a constructor. We're calling a helper function to create the new object, and then we have the prototype, which is basically like a payload of all the methods for that class. That gets attached as the index metatable, and then we call the super method, which does basically everything in the new method, which sets the fields, and then returns that object that it created. So it's almost like a sandwich I put together. There's all the variable declarations, there's the methods, and that all gets returned as part of the constructor. And it basically lets you using reflection, you can get all the fields, you can get all the methods. And maintain, and it lets the runtime know how that object is structured. And then for inheritance here, I'm introducing this super method, which is basically does the field modifications that I talked about. And then if you have a class that inherits another class, basically we're just adding another meta table to that prototype chain. So it's that other class that you're inheriting. And then that super method, which does all the field changes, you basically call both supers. So this basically lets me treat Lua as having object-oriented programming and have all of the fields and variables that they're distinguishable in the runtime for reflection purposes. It's a little dry, but just kind of wanted to take a moment to mention how that works, because there's a lot of people that I think don't like to do OOP and Lua, and in this way you can, at least the compiler's handling that for you. So it takes care of a lot of the pain. One of the other things going on is there are a lot of Lua libraries that you want to use inside your Haxe generated code, and there's some metadata available, so you basically can mark up extern classes and whatnot with these to let you access Haxe generated code from other Lua code that you might be using. And if you've used the JavaScript targets, either through like a browser JavaScript or Node, you'll be familiar with these. They're basically expose binds a method or a class to the global namespace, so you can write up a really nicely structured Haxe class ontology, and then you can choose which ones you want to export out and then use those externally. And then, yeah, so self-call, there's some other features in there that let you just sort of work with externs and exported Haxe code in a comfortable way. And yeah. So the other thing I wanted to offer, like in addition to the Lua target, I started this about a year ago, and I didn't know much of anything about the Haxe Compiler and or Lua and or OCaml. So this hidden in the Git repo now is virtually, obviously every commit I've ever made, and I tried to do a decent job of describing my thought process of like, what do I do first? What's the first file I need to alter? Where do I need to, how do I convince the compiler that it has a new target and that it should, generate code in this fashion? So it's kind of unfiltered. I don't think I use any curse words, but it's me kind of just talking aloud to my terminal. So and most of the commits have maybe not quite this long. They're not paragraph level, but pretty good information. And that first command there, that git log reverse grep Lua, will basically catch all of the Lua references, and those are basically me. So it starts from the beginning. So we have a functioning target, but I do have to warn there's some kinks to sort out. There's still some things that I kind of wish I could have polished up a little bit better. So one of them is Lua has this restriction where you can't declare more than 200 local variables. And first of all, I would say if you're doing that on purpose, you'd probably want to think about maybe refactoring a little bit. But in Haxe, we have abstracts, we have inlining, and we have all these ways where variables are created kind of automatically. So it's something to be aware of, and it's something that you don't want to, whenever you try to use code designed for other targets, is something you want to make sure that maybe you turn off some of the inlining, try to prevent some of this extra variable creation. The sys API is also incomplete right now. I'm working kind of case by case with some folks that are trying to get the basic file system stuff working, and it is. The problem is that Lua once again doesn't provide kind of a standardized interface to that, so it's literally like going in and finding externs that I can use or libraries that I can extern to get like consistent file and process activity across all these different platforms. And then, as I mentioned before, it has a special notion of nil, which is it doesn't really distinguish like a missing value from an empty value. Whenever you try to do things like concatenate nil, it has problems, whereas most of the other Haxe targets will act gracefully and just concatenate the string null. That's not a, yeah. There's also, one of the other things that Lua does is it will have multi-return methods, so you can return multiple variables from a single method call. And this is part of some ongoing discussion, and we're trying to figure out a good way of allowing the Haxe syntax to describe that and then return it and let you operate on those, let you extern a method that does that and then operate on those values in a sensible way. And then, of course, this is sort of my first pass at all of this. So, you know, I'm working on optimizing the generated Lua output a little bit, making it as readable as possible, but then also as compact as possible, so that you can, you know, fit this on smaller devices in terms of file size. Right now, there's really only 3 bugs. However, not very many people have used it yet, and it's sort of like the extreme early adopters right now. And so the other thing I wanted to talk about was just some special aspects of the Lua target that I don't think I'll ever be able to fix, and you just sort of want to understand and avoid. This 200 local variable case is not something I'm going to, like, even when I have a workaround in mind for it, I'm working on that. But in general, trying to use more than 200 local variables means that they can't really be local anymore, and I'll need to find some mechanism to do that. And when I do that, that means all the variables after that, after 200, are going to be slow, some kind of a slower access. So you want to, in general, avoid creating a lot of temporary variables. And that basically boils down to, you know, be sensible about, you know, refactoring and make sure you don't have too many local declarations, and then avoid excessive inlining of code that creates temporary variables. The other thing that's a little that Lua is not particularly good at is it's not that it's not good at it. That's not fair. It just doesn't have it doesn't have this notion of an instance method versus a static method. So there's some helper methods that basically constantly have to, like, wrap and unwrap methods whenever you assign them to different fields, so that they can bind to the instance and behave the way the rest of the targets do. But whenever you do that, you're adding more overhead because I have to wrap everything. So these things in general, they're not a great idea. So they're relatively rare in the Haxe code base, but you don't want to assign instances back and forth between, or you don't want to assign methods back and forth between instances. The other thing is this is like basic Lua protocol. You want to avoid using Lua arg, which is accessing the argument for a method. It's basically a table of all the arguments, and avoid using the Haxe extern rest when you can, because these two methods, when translated to Lua code, they'll disable a lot of JIT optimizations. So whenever you make methods, if you want to make them fast in LuaJIT, be explicit about the arguments, enumerate them all, and then use those. Most people do in Haxe. That's pretty much the norm anyways. And then there's a lot of ways to bootstrap Lua code. As I mentioned, you can basically insert raw Lua code as helper methods for your Haxe code. And when you do that, typical warning: don't, like, overwrite an important field or a variable name. So try to use unique identifiers there. There's not many safeguards, but I do that a lot in the standard library. So yeah, I mean, taking a step back, I'm pretty happy that it's that besides a few warts, it's feature complete outside of some missing sys methods. And, you know, my takeaway here was that, you know, OCaml, I think, is people are a little bit hesitant to check it out because it is very different. But really, it's not so bad. You pick it up, and Simon and company have done a good job of kind of reorganizing the code and structuring it in a better way, and helping you understand where the you know, which files are responsible. Basically, everything that's prefixed with gen is a target. So if you look up gen Lua, that's most of the code. That's basically all the code I wrote. with the exception of some standard library modifications. And then in general about Lua, I feel like it's made very few mistakes. Like it's got some quirks, but it's a very solid little language. The counterpoint to that is that it also has very few batteries included. It doesn't try to do very much. It kind of leaves a lot to other library authors. And one of the problems that's come out of that is that the Lua ecosystem is getting a little fragmented right now because there's breaking changes between 5.2 and 5.3, and then LuaJIT is actually a completely independent project, and it's more like Lua 5.2.5. Like it's got features of both. So right now I'm focusing on 5.2 and LuaJIT. Those are the sort of the fastest and the versions in widest use, and I'm trying to handle some of the other issues coming out of Lua 5.3. The other big lesson I learned was had a son in the last year and a half or so, which was really exciting for me. And the funny thing there was the big lesson learned was finding free time was extremely easy at first because he slept most of the day, and I had paternity leave, and so I took out huge chunks of this project, and I had a full head of steam. And then lately he doesn't sleep so well, so it's some of the commits and things have trickled down to next to nothing. So if anyone's thinking having a kid, you got to do as much work as you can right up front. And so what you're seeing on the right here is the commit graph, basically going back all the way to when Haxe first started. And the other thing that was kind of fun was just kind of seeing my name pop up there finally with some of the other contributors. But I felt like I did a lot of work, and it's this tiny little blip down here. And meanwhile, you got Simon and Nicholas up here, and they are just absolute machines. They just churn out so much stuff. So I think I still am impressed by kind of what the things that they accomplish, and even after doing a core target, there's still even another level of expertise above that. And then if I were to do it over again, I think I would start from scratch and just kind of take JavaScript seemed close enough for me, but I think there's enough little catches and hooks that if you're not really familiar with how everything comes together, you'll end up forcing a lot of round pegs into square holes when really you probably just should take a step back and do what's best for the target. That came out in my work in the sense of a lot of the things that I did was just rewriting expressions as inline strings for generated Lua code. There's a ton of debugging methods and things that help print out stuff in TypeML that I just kind of skipped or missed that would have been helpful. And the other thing I would have done is bother the other core developers more. I think I kind of just kind of learned as much as I could on my own, but they sometimes would just solve things in 5 minutes what would take me a couple days. And then so now we're to the point where it's like the target was done more or less, or at least available in the core Haxe Foundation repo. And this was one of the things that really made me happy. Less than 24 hours after that happened, one of the game framework developers wrote a wrapper for the whole thing and put that up. So it's kind of neat to see some people already, kicking the wheels on this and trying it out in different ways. So Love is another one is a Lua framework for games, and there's already a wrapper and a wrapper generator for that. Engine Hex is something I'm working on. I mentioned that Nginx has this Lua scripting ability, and Nginx is already fast, and the LuaJIT environment's fast. So I think this has the makings of a really great web development platform for extremely high throughput websites. And it's everything. You write your. You can't really see this here, but there's like a hello world, and then you just extern the ngx module, and you get access to everything that Nginx lets you do. The other cool thing that I started working on was getting back into Warcraft, which I never thought I'd do again. I was hoping I'd never do again. But it has its own API, and these two environments are great for me because I get to see how Lua is kind of used in the wild and how best to sort of map all of the functionality to a couple of these minor variations, and I'm trying to get better at that. So actually, how much time do I have? Let's see. Does anyone know? 12 minutes? Okay, so let's play Warcraft. So I've got my my character here. I'm too cheap to actually pay for that, but okay. So we got Mr. Haxe Lua here. We're going to enter Warcraft here. And we don't need too much sound here. But basically, I've got this little, I basically wrote a macro and then I bound it to one of these menu bar actions. So it's right here. And it just says, hello world, which is great. I mean, not the most interesting example, but yeah, that's great, that's great. But really we wanted to say, so I just want to show a little bit of the workflow here. So you just say, rather than hello world, we want to say hello Warcraft. You compile that. And then over here on, over here back in World of Warcraft land, you need to reload the UI to get those new changes. And now we have Hello Warcraft, which is nice. So you get kind of a nice, it's not like completely live, but very quick iterations for doing little tweaks. And we can go one step further here. Let's see, let's pull this up. So just wanted to expose a little bit more of the logic available. So now we're looking at, maybe I can bump that up. Sorry about that. Now what we're doing, instead of just saying hello world, we want to inspect whether the character is an enemy or a friend, and then tell them, to go get bent, or tell them like hi, depending on the current status. So once again, we'll compile this, and once again, we'll reload. And now this guy here is an enemy. So we're going to say, I will destroy you. So it knows we can use the API to get that information and then change the Haxe logic appropriately. And then this guy over here is a friend, and say, oh hey, we can give him a little wave, and yeah. And everything's kind of working off this, working off the API. So once that's completely populated, you'll be able to kind of browse the methods and variables and pick out, whatever you want to do. And yeah, so that's about it. Come back into here. Yeah, so that's up on Haxecraft, and I'm probably, to be honest, I'm probably not going to maintain this. So if anyone else wants to lay claim to that name, feel free, and I'll give over the kind of minimal API support that I've got externed right now. So yeah, let's recap. The things I wanted to communicate was just that Lua was, I thought, is a pretty great target. It's small, speedy. It's great for sandboxing, gives you a lot of flexibility, and pops up in a lot of interesting places. I think a lot of the goals and sort of the way the Lua community operates, what they're interested in, it's really similar to ours. And so after this talk, I'm actually signed up to do a very similar presentation at the Lua workshop later in October here. And I think that Lua offers a couple more niches, especially with game scripting and some of the different scripting things they do, that if the Haxe community is interested in that, then that's Lua is definitely where it's at right now. So the versions, I talked a little bit about the fragmentation. I'm considering Lua 5.2 and then Lua JIT as sort of the first class, maybe the best supported versions right now. And then 5.3 works if you use the backwards compatibility flags when you do 5.3. But that's still a work in progress to have that kind of idiot proof. You can use the Haxe Lua commit messages from the repo if you're interested in just sort of how you put together a Haxe target and like what goes into it and what the basic flow is. If you do a target, you're not doing the whole thing. You're using all of the great AST translations, and there's a lot of work that happens before you actually render the output. And once again, like Simon and Nicholas have done some great work. Basically, if there's a language feature that hits every target, like those guys do that. And then as a target author, you just sort of render that AST back into the code that the target understands. So it's not starting from scratch when you're doing a target, which is it's kind of a great introduction. And then I talked about a few of the early projects and just kind of showed just through virtue of Lua being very lightweight and easy to use, a lot of them are very nice to work with. They're pleasant. World of Warcraft has its own like Lua console and debugger, and I have no problem. I had no idea how it worked and literally got it working in like 15-30 minutes. And there's already some folks doing some other wrappers and projects with it, which I think are great. I think it's great. And that brings us to the end. And yeah, I'd be happy to answer any questions or hear any other comments. Sure.
I think Vim supports Lua scripting, right?
Yeah.
Maybe it makes sense to write the Haxe for Vim.
Yeah, that was one of my original motivations was that the Lua scripting layer for Vim, and especially NeoVim, which was one of the other projects I mentioned, I thought was a lot faster than even Python. So it was something. I know that there's another project called Tides that's out there that's basically looking into providing a project that does multi-platform IDE support. And so my roundabout rationale for this was like, I want Lua because it's fast, and then I want to contribute back to an IDE project to improve Haxe's ability to be used on editors on many different editors on many different platforms. Because right now things are a little bit uneven. Like I maintain the Vim plugin. There's Sublime Text. There's IntelliJ. But different editors let you do different things. And I think really like we should probably have one code base that helps you do all that and kind of improve improve things across the board. Great.
Is there any Haxe?
Oh.
Is there any Haxe feature or concept where you'd say that was the hardest to get right on Lua? Any specific one?
That's a good question. I think I hit so many stumbling blocks, and I think it was just I think in some cases I hit really bad ones, and then you'd figure it out in 5 minutes, and I'd be really embarrassed. And but yeah, some of the trickiest ones were 64-bit integers, because Lua doesn't have integers, and it has floats, which aren't really the same thing. So it required a lot of clamping and kind of different variations of binary and bitwise ops. So that was tricky. Figuring out kind of how I wanted OOP to work and maintain all of the reflection the features that I wanted. That was tricky. And yeah, there was just a lot of problems. Like I think you get to that hello world state very quickly, and I think for me that happened in about a day or two. I could write out that simple Haxe main, and generate the output, but then it's the last, it's the last detail. It's that unit test suite that's just brutal, and it covers a lot of problems. So yeah, too many to name.
Yeah, so you say you use externs for various things. Say Lua externs. Does that then extern into native, or for instance, the file API, is that native underneath? Yeah, so
basically, Lua is by definition a scripting layer over like vanilla C, and so C doesn't have POSIX or any of the other features of like a modern, like any kind of a modern system. So if you want to access that in Lua, you first of all have to say, well, am I targeting Windows or Linux, or what am I doing? And then you have to wrap that API. So Lua is basically externing those raw system commands, and I'm in turn externing the Lua commands. So there's a layer of abstraction there. Lua is only going to basically handle one API or another, and I've got to figure out a way to abstract that away so that I can you basically can you install the system layer for your system, and then everything will work through one consistent Haxe API, so you don't need to worry about it after that. So that's still a work in progress. Well, great. Thank you, everyone. Yeah.